Hello everyone, welcome back to CodeMaster. In today's video, we will learn about selection sort, one of the fundamental sorting algorithms. We will cover its concepts, step-by-step working, implementation in Python, and a comparison with other sorting techniques. By the end of this video, you will be able to understand selection sort clearly and write your own Python code for it. Make sure to watch till the end. Before we dive into the implementation, let's first understand what selection sort is and how it works. Selection sort is a simple sorting algorithm that works by repeatedly finding the smallest element from the unsorted part and swapping it with the first unsorted element. It divides the list into two parts, the sorted part at the beginning, the unsorted part rest of the list. Always selects the smallest element from the remaining unsorted portion. Works in place, meaning it does not require extra memory. Time complexity is order of n square, not efficient for larger datasets. Now, let's break down selection sort step by step using a example array. So, example array is 53842. In the past one, we will find the smallest element in 53842 and the result will be 2. And it will swap with the first element, which is 5. 2 will come in place of 5. Array after pass 1 will be 2, 3, 8, 4 and 5. In pass 2, we will find the smallest element in 3, 8, 4 and 5. The smallest element is 3. No swap is required. Array after pass 2 will be 2, 3, 8, 4 and 5. In pass 3, we will find the smallest element in 8, 4 and 5. The smallest element in these 3 is 4. So we will swap it with 8. So array after pass 3 will be 2, 3, 4, 8 and 5. In pass 4, we will find the smallest element in 8 and 5. The smallest element is 5. So we will swap 5 with 8. And the result will be 2, 3, 4, 5 and 8. Then finally, the sorted array will be 2, 3, 4, 5 and 8. Notice that in every pass, we pick the smallest number and move it to the correct position. Now, let's analyze how efficient selection sort is. The time complexity. Best case is order of n square, worst case is order of n square, and average case is also order of n square. The space complexity is order of 1. It doesn't use extra memory. Why is selection sort inefficient? It always takes order of n square time even if the array is already sorted. It performs n square comparisons, making it slow for larger datasets. This is why selection sort is mainly used for small datasets or educational purposes. Now that we understand the logic, let's write the Python code for selection sort. This is the Python code for selection sort. So now let's go through the code line by line to understand how it works. In the first step, selection sort of array, we define a function selection sort that takes an array as an input. In the second step, for I in range n-1, we loop through the array considering I as the index of the first unsorted elements. In step 3, minimum index equal to I. We assume the first unsorted element is the smallest. In step 4, for j in range I plus 1 to n, we iterate through the rest of the array to find the smallest element. In step 5, if array of j greater than array of minimum index equal to j. If we find a smaller element, we update minimum index. In step 6, array of I, array of minimum of index equal to array of minimum of index, array of y. In this, we swap the smallest element found with the first unsorted element. Finally, the function returns the sorted array. Unlike bubble sort, selection sort performs fewer swaps. However, its time complexity remains order of n square, making it inefficient for larger datasets. So this is the step-by-step explanation I did in the previous slide. So go through it. So let's compare selection sort with other sorting techniques. This is the comparison between selection sort with bubble sort, insertion sort, merge sort, and quick sort. Selection sort is easy to implement but not the best choice for performance. That we can see from this table. So in this video, we learned that selection sort repeatedly finds the smallest element and swaps it. It is easy to understand but inefficient for larger datasets. Time complexity is always order of n square, making it slow for larger inputs, best used for small datasets or learning purposes. In the next video, we will learn about insert and sort. That's it for today's video on selection sort. I hope this video helped you understand the algorithm in detail. If you found this video helpful, don't forget to like, share and subscribe to CodeMaster for more coding tutorials. Stay tuned for next video and see you in the next one. Happy coding.